Hello and welcome back. My name is Steven, and I'm here to teach you a little bit more about developing in C# for .NET platform against Windows machines. Now I say Windows, but you could obviously use .NET for Linux-based systems using libraries like Mono or Wine, but that's beyond the scope of this particular series, at least for the foreseeable future. If you're interested in that, let me know in the comments. I'd be happy to look into some IoT C# and how to teach you deployment using Mono. Xamarin and other tools like Stack Overflow have covered the documentation for this process in a lot of detail, so you may not even need me to be able to walk you through that. Today we're talking about conditionals and loops, and they kind of go hand in hand in that loops cannot really exist without conditionals. So obviously we're going to cover conditionals first. And there's quite a bit of information that goes into conditionals, especially when you start to consider how they pertain to other systems throughout programming. Conditionals are a fundamental that you'll find even down to the lowest or closest to hardware level programming out there, firmware. Using conditionals to say, if a condition is true, do this. Otherwise, do this, to send electrons to different controllers, different subprocesses, and microchips across different boards. So we're going to jump right into conditionals with the most basic one and the most prolific one, the if statement. The if statement is a really simple syntax that takes the word if followed by a parameter, which is just something that would evaluate to true or false in this case, and then also has a block below it. A block is a term used for code that is surrounded in curly brackets, and I'll show you that here in a second. So here we have our Visual Studio application using our first application solution that we've developed so far. If you haven't watched the other two episodes, I highly suggest it. They'll be in this playlist as well as linked together in some way, shape, or form in the description. It's a really basic form that originally we entered a value into this text box, hit this button add value, that then added the text box value to the list box. Right now we're just going to enter into this block that says that when the button is clicked, do something. So essentially, do something. So let's talk about the if statement. The if statement looks a little something like this, and can also say that. So in other languages, this is also known as an if-then-else statement. This in C# is just known as an if statement, and you can add the else if or else clauses. Essentially this says that if something evaluates to true, do this. This is a block of code, or would be a block of code. Otherwise, if this does not equal that, but it does equal this if statement, do this block of code. If neither of these cases are true, then we go down to this else, which is kind of a catch-all for non-caught values above, and it will output something here or do some sort of logic there. Let's break down just the if. If is an evaluation, and it takes three essential or three basic arguments, which is going to be your operators, two operands, and one operator. What is an operator? What is an operand? Consider don't mind my typos. Backspace is fantastic. So consider this statement, or these statements. If first equals second. In this case, the equals equals sign, or syntax, is considered an operator because it performs some sort of operation or verification between the two arguments to the left and to the right of the operator. You can treat this much like a plus sign, which is also an operator, or a subtraction symbol, the hyphen or dash or what have you, in mathematics. In this case, the equals equals simply means is equivalent to. In this case, does the value of first have the equivalency of the value of the second? If you were to put first on a scale, like one of those old-timey weight scales, if you were to put first on this side of the scale and second on this side of the scale, would they be the same? Would they weigh the same? In this case, would they be the same value? Would they both be true? Would they both be false? In this case, neither of those cases is true. In fact, first is equal to true and second is equal to false because we have assigned those values with the assignment operator to true and false. So therefore, first does not equal second because true does not equal false. So this block here would never be entered. And as such, Visual Studio often will throw or have some sort of syntax to highlight it. Now, I apparently have that disabled, but many times you'll see in Visual Studio that true equals equals false is highlighted, saying it's a potentially undesirable condition to check because it will always resolve to false. Now, there are some computer science things that you can get into that make that untrue, but we're not going to deal with that, at least not for quite a while. So why the double equals? Why would we not just do single equals? Well, as I said before, a single equals is already defined as an assignment operator. This value, or this variable, is assigned this value. Makes sense? This value can't be assigned in an if statement. It has to be verified. It has to return a Boolean value, as we mentioned in the previous video, a true-false value that can then be entered into upon truth or passed by or overlooked upon false. So the equals equals means is equivalent to. Is operand number 1 equivalent to operand number 2 in their values? This can also be applied to pretty much any other primitive or object you can think of. When you get into complex objects, though, it can get a little bit more frustrating because the way they behave in memory does not always return the same value that you would think it would. But in this case, first could equal, say, Stephen, and second could equal Albert. Well, now when we go down here and do this, you have first is equivalent to second, as in is first equivalent to second. Now, obviously, by looking at this, it's obvious that no, Stephen, the string of characters Stephen is not equivalent to the string of characters read Albert. But if we were to change Albert to Stephen, then our conditional would evaluate to true and enter into the curly braces and do the code here. And I'll show you. Because it's really hard to imagine kind of what people are saying in this. So we'll just click the add value button. We're not going to interact with these two here. But it'll show hello world because these two are the same. If I did this and I hit start, we wouldn't get our message box. Pretty straightforward, but not always intuitive at first, especially if you're not coming from a programming background. So what else can it apply to? You can use conditionals to check equivalent values for any primitive, like I said, ints, bools, longs, floats, strings, characters. I think you can even use it with arrays, though I imagine that would get a little bit funky from time to time. There are better ways to check equivalency, or at least value equivalency, for arrays and dynamic lists, which we didn't cover in our primitives because they are not inherently primitives. We're going to get into those when we get into loops here shortly, because they're pretty imperative, as they are the basis for everything that you will get into with loops. Let's move on to a different kind of operator. This would be, the operator we're going to discuss is the opposite of this statement. We don't want to check if first and second are equivalent. We want to check to see if they are not equivalent. This operator looks very familiar in how you would imagine grammar because it's an exclamation point. Exclamation point in most languages, especially .NET languages, the exclamation point means not. Not equals in this case. So first is not equivalent to second. You could imagine it almost like this. It is not equivalent rather than not set to. If you were using a bool value like true, and you put the exclamation point, which in programming terms is known as a bang, in front of true, this would evaluate to if false. Unreachable code detected because this is never true. Now if I did if not false, then we are saying if true, do this. It can be a little bit mind-boggling to get into what are known as inferred or interpreted falses. But that's okay. We don't have to get too deep involved, and if you're more comfortable writing out the not equals notation, that's fine too. If you're getting into a computer programming role or a developer's role and you happen to see the other notation, though, it's worth mentioning that you shouldn't be surprised. Shorthand is something that comes to a lot of developers very frequently. Be prepared to be out of your comfort zone for quite a bit of the initial training stage, and kind of go with the flow. You'll find your rhythm and you'll find your cadence as you get moving, and you'll learn a lot faster when you have a project in front of you. What are some other operators that you can think of? Let's do something like this. And I'll give you just a second. Pause the video if you need to, but think about how would we check equivalency for first or second? That should be review. But also think about what other mathematical operators could we use to check if true or false. Done thinking? Well, we're going to jump into it. Like I said, pause the video before this, because if you need a little bit more time to think through things, it's worth it to try to work it out yourself. But we're going to jump right in 3, 2, 1. Is first greater than second? Is first less than second? Is first greater than or equal to second? Is first less than or equal to second? These operators are going to come in handy as we get into loops shortly. It's also worth mentioning, outside of the conditionals conversation, that you'll also see something like this, like this, like this, or even like that. Those operators we'll get into a little bit when we cover the for loop specifically, because it tends to use increments and decrements to delimit how you are going to do or denote what you are going to do with your loop. We're not going to deal with that right now, That's later in the video. But I wanted to bring it up so that you're not super surprised when we get into that section and say, oh, geez, that's an operator you failed to mention. Just trying to make it a little bit more comfortable for you now so that when we rip the Band-Aid off into the complicated stuff later, it's not as bad as you think it is. So we can check greater than, equal to, greater than or equal to, less than or equal to, equivalency, not equivalency, etc. That's pretty solid. And you can do it with non-primitives as well. You can use it with buttons, you can use it with text boxes, you can use it with get types, things like that. There are so many things you can do to check equivalency in an if statement. And then the else if is just a branch off of that, and the else is the default value or the default fall through from there. If you have any questions about some of this stuff, let me know. Throw it in the comments below. I do read comments. Feel free to reach out and say, hey, I'm really lost, I'm really confused, and I'll try to offer a little bit more personalized note or personalized reply to whatever issue you may be running into. I can also answer a little bit more complex questions if you have them, though I'd prefer they stay within the context of these videos. That way I can at least brace myself for some more complexity. So now we've covered the if conditional. Let's cover what is known as a switch case. And it's going to take me a second to write it out real quick. The break operator, or the break keyword. The break keyword is not one that you've seen so far, and that's for very good reason. It's because it is a dynamic keyword that releases the current operation from the parent scope. If that doesn't make sense to you, that's okay. We'll cover it a little bit more in depth where you see it more often in loops. The reason that it's in this particular case is so that we don't have to worry about code falling through to cases that are not pertinent to our logic. It's a really abstract way of saying don't worry about it until we get to loops. It'll be a little bit more obvious and a little bit easier to wrap your brain around when you get to a loop. In this case, the switch essentially saves our values in our lookups, which are these cases down here, into a cache of sorts. And will only look up the value or the operation and perform that operation when the switch is equivalent to the case. So basically, if the switch value or parameter is equivalent to the case value here, then we'll do this. If it is equal to this, or if it is equal to world, exclamation point, then do whatever is in here. If none of these cases are the particular logic that you need or that this first condition meets, then we fall through to the default. Default is an optional keyword and an optional case. You don't have to have it. Many developers prefer to leave it out and just throw their logic in after the switch case for their default, though if wrapped in a loop is not recommended. This is a pretty basic overview of a switch, and you'll see me use it from time to time instead of an if-else statement because I actually prefer the readability of a switch case. They seem cleaner, the white spacing, the indentation, everything like that just makes them feel a little bit better, but nothing beats a good old-fashioned if statement. I do prefer the performance of switch, however, it's just not heavily used. And that's okay. If you're memory conscious, It could be that you don't want to use a switch because it stores somewhat of a cache in the memory itself, or you may want it for the performance only and you don't care nearly as much about memory. The use cases of a particular switch are pretty broad, and it's really up to your discretion on whether or not you use this versus an if else or something along those lines. Now let's take a look at something known as a ternary operation. A ternary operation is just an inline if-else statement. It's super quick, super simple, and easy to write out. It's not meant for anything super complicated, though it can look a little bit intimidating the first time you see it. So first, we're going to have our Boolean first equal to true, our Boolean second equal to false, and then we're going to get a string value out of this based on whether or not true is equivalent to second. So string result is equal to first, not equal to second. I did not equal to in this case. Question mark says from here we have the results if true. And in this case we're going to say true. And then you do a colon for your false result. So if first does not equal second, then true. However, if first is equal to second, return false. And let's show you that in runtime, because it can be a little bit of a mind bender. And that's okay. It's okay to be confused, but if you are confused, even by the end of this video, please let me know. Again, I can go into as much or as little detail as you'd like. So when I hit the add value button, we get this pop-up box of true. And that's because first does not equal second. True does not equal false. Therefore, we return the first value after the question mark. If, however, the second were equal to true, you can probably guess we would get false. Because first does not equal second evaluates to false, because they are both the same value. And that's it. That's all ternary operators are. You'll see some from time to time nested. I'm not a huge fan of nesting ternary operators. They get confusing to read. They are not legible for me personally, and more often than not, I don't see them commented well. So you can sit there and look at it for a few minutes and probably figure out what a ternary operator does when it's nested, but I would rather just have a straight output of the value that I need. I'd rather have it out in blocks or in a switch case that has some white space to play around with. This conditional applies the same logic that we talked about for the if-else blocks. Essentially, anything that could go in an if statement can go here without the parentheses. Next up, we're going to get into loops. In order to get into loops, though, we need to talk briefly about the concept of arrays. Not raise, not like monetary raise like you would get at a job. Arrays. An array. The array is a collection of variables. If I were to do something like this, I would get an array of strings. Okay, I keep throwing around the term array. So what does an array look like? Well, I get that this is what an array is built around. This is how it's established. But what is an array? An array is a list of strings. Be careful of using the term list in this case. I'm using it because this is an introductory into collections. In this case, it is a collection, a stack, specifically, of string values entered into it. So you might type out a list of groceries or groceries that you need, depending on how you say it. Say you need eggs, milk, and bacon. All right. Typically, you would see commas here. You would see just some line breaks to drop them down a line. But essentially, this is a 3-item array. This is a known number of items that you have in your collection. And that's how arrays are typically built, is you know the exact number of items you need to fit in your memory space. I'm pausing and breaking a lot because I don't work with arrays a ton, because quite honestly, C# has something that I consider a lot better. Now, it is more memory intensive, and you have to be careful with that, but dynamic lists are my preferred way of handling data. Though arrays are nice for memory conscious people, I need to bring them up to you because they are a basic concept that is necessary for growth in the programming world. Because if you learn C# now, that's fantastic. And if you learn all the wonderful technologies that C# has offered into the industry, that's also fantastic. But you really should be able to take a lot of the concepts I'm teaching you here and apply them to other programming languages. Arrays are not my forte, and that's okay as well, but they are something worth knowing. So we have 3 known items, and for an array, you have to know the number of items you are going to store in it. Think of this as a 3-item checklist for your groceries. You only have 3 lines, and they only fit 1 item per line. None of that like running off vertically in the margin sloppily like we did in middle school or I did in college, because I don't plan well for my my homework assignments. So in order to get these values, eggs, milk, and bacon, which we'll use for our example, into our array, you need to grab the variable string array, in this case str array, and you have to understand indexing. An index is just a 0-based numeric value assigned to each of your values for where they are. Think like in a dictionary or in the back of a book you see an index, especially in scholastic books, an index of every lookup or worthy lookup that you could have. This is exactly the same thing, except it's numerically based rather than string based. So some of this is going to take some memorization. I can totally spell eggs. Leave me alone. But this is how you assign a value to a particular place in the list. 0 is the first position, and you'll find this in programming pretty much universally. Programming languages are 0-based, which means they don't go from 1 to 9, or 1 to 10 rather. They go from 0 to 9 to show 10 items. Because you would have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is 10 items because you include the 0. Normally what you would see in your everyday world, because people like to count from 1, is that computers don't like 1 because technically 0 is a value. It's not 0, or it's not null, as you'll hear the term, and we'll cover null. 0 is a value. Keep that in mind. Off by 1 errors are some of the most notorious non-syntactical errors, known as semantic errors, that you will find throughout the business and the industry. 0 is an important index to keep track of because it is the first index you will find anywhere in an array, a list box, an items control, etc., etc., etc. So to add a value to the array, we simply need to know what index we want that value inserted into and the value itself. So string array at the index of 0, that's what these square brackets delimit, is the index of the array that we would like to put the value into, is equivalent to eggs. In this case, we're going down to the second item, which is the index of 1 for milk, and now bacon is going to be the index of 2. This is our 3 items in our array of strings shown with values being input into that array. It's a complex concept, and I think you'll find lists a lot easier because they're dynamic by nature, and you don't have to know the number, and you don't actually have to know the index for a lot of what you're doing. Now, I promised that I would get into loops from here, but I think I'm going to cover dynamic lists as a predecessor, kind of like a transition into that video. And I'll hope to try to get that list or the looping into another video this week so that we don't throw off the schedule for the rest of the learning. Every other part of this video I've mentioned talking about getting into loops, but I am running into time that is going to make this video a little bit longer than I would prefer it to be. So let's cover lists, get them out of the way, and then I'll hope to release a video later this week covering the loops that I would love for you to learn. If I don't get to it this week, rest assured our schedule is not completely screwed up. I left in a couple of pads here and there. So next week, at the very latest on Wednesday, you can plan on having your loops. So now let's talk about lists. Dynamic lists are my favorite collections. And that's only because I'm not overly familiar with one other type of list that we can talk about when we get into binding. Dynamic lists look and feel like this. List, angle bracket, in this case, it looks like a less than sign next to a greater than sign because it is, but they're in this case known as angle brackets. Your data type, what you are storing in the string, and I usually name them with the convention LST for list. Let's stick with that groceries example. We're going to create a new version of them, or a new version of the list, and it's known as instantiation. When you create a new instance of a dynamic or a complex object. We haven't gotten into constructors or complex objects yet, and that's coming, don't worry. But right now, just know that new means new instance of. And really, you don't even have to know that right now. Just know that this is how you would create a list. It's the list keyword followed by an opening angle bracket, the data type that you are storing in the list, close angle bracket, space, the name of your list variable equals new, again, space, new, space, list, angle bracket, the same data type that you entered in at the beginning of the statement, close curly bracket, close angle bracket, open and close parentheses, semicolon. You can read that verbatim. You can hear what I said. That's fine, whatever. But it's not important for you to know why that works at the moment. Just that that is the syntax for creating a new list. So to add items to this list, we don't have to know an index. We can insert at any point we want to, or we can just add to the list directly. So list groceries dot add. In this case, we're going to do eggs. And I think I had milk. And then, what was the other one? Bacon. And that's it. List groceries, .add, and then the string value of what we'd like to add. Those are lists. And that's as easy as they can possibly get. You can do this with integers, you can do this with longs, bools, whatever you would like. We'll get into key value pairs as well when we get into mapping some JSON objects and things like that. Key value pairs are wonderful tools that allow you to store multiple data items in a singular variable that you can also add to a list. Again, real complicated way of saying don't worry about it right now, we'll get to it. If you have any questions, feel free to leave them in the comments below, as I've said throughout this entire video and in my other videos. If you haven't had a chance to check out the first or second videos that I put out, please do. It helps a lot for you to get on the ground and start running with some of this code. The first episode considers how to use Visual Studio 2019 as a tool. The second about primitives and some basic data types that you really should know. I'm hoping to make these episodes a little bit more bite-sized, specifically so that you don't have to sit down and spend an hour on what I'm talking about, but rather spend an hour learning in your own experiences. Thanks again, and until next time, have a good one.